Suppose we construct a circle on the coordinate plane such that the center of the circle is at the point 0, 0, right at the origin, and the radius of the circle is 1. So we have it crosses the x-axis at 1, 0, and negative 1, 0, crosses the y-axis at 0, 1, and 0, negative 1. Suppose further that we have a point that we rotate around that circle in a counterclockwise direction, and we measure that angle of rotation here, and we form a triangle as we do it, and we'll see what happens when we get past 90 degrees. Well, one of the things that we know from right triangle trig is that the sine of this angle, 46 degrees, is equal to the ratio of the side opposite, which is that red dashed side here, over the length of the hypotenuse. Well, the hypotenuse we know to have a length of 1. Therefore, when we divide the length of this by 1, we just get the length of the side, which we can read from the y-coordinate of that red point, which is 0.72. So the sine of 46 degrees coincides with the y value of this point. Similarly, because the cosine is the ratio of the side adjacent to that 46 degree angle divided by the hypotenuse, we get that the x value of this red point represents the cosine of the angle of rotation. So the sine of 46 degrees is equal to 0.72, and the cosine of 46 degrees is equal to 0.69. As we continue this, we see that our sine value increases until we actually reach a point where it's exactly equal to 1, and our cosine is exactly equal to 0. So we no longer can construct a right triangle, but we can still measure our sine and cosine because of this notion that we can look at the coordinates of the point that we are rotating. So as we continue to rotate, we now have rotated this a total of 120 degrees, and so the angle that we're taking the sine and cosine of is no longer this angle inside the right triangle, it's actually this exterior angle here, which is 120 degrees. Notice that we now have taken the triangle that is the reflection across the y-axis of the triangle we had when we were at 60 degrees. And so what that means is that here we had a sine and cosine of, or the cosine was 0.5 and the sine was 0.87. Well, now at 120 degrees, we can see that those values now are negative for the cosine, negative 0.5, and remain positive 0.87. If we continue rotating around until we get to this angle right here, 240 degrees, we again have the same absolute values for our sine and cosine, but now both sine and cosine are positive. Again, the sine is the y value of negative 0.87, and the cosine is the x value of negative 0.5. And we can do this one more time, and now we reach an angle of rotation of 300 degrees. Again, absolute values for the cosine, 0.87, and the sine, 0.5 are the same, but now, the sine, negative 0.87, has the same absolute value as when we were at 60 degrees, but its sine is now negative. Okay. Another thing we know from right triangle trig is that there were certain triangles where we could compute the exact sine and cosine. And those were special right triangles, and we found them when we had a 30, 60, 90 right triangle, which is half of an equilateral triangle. And we also found it when we had a right triangle with a measures of 45 degrees and 45 degrees forming a right isosceles triangle. So when we were at rotation of 30 degrees here, we have our 30, 60, 90 triangle, and we know that if this is 1, this length right here will be exactly half of that, or 0.5, and then we know if we multiply this length by square root of 3, we'll get the length of this side here. So we have exact value of the square root of 3 over 2 for our cosine and 1/2 for our sine. When we go up to 60 degrees, we have the same things but reverse. Now the sine is root 3 over 2 and the cosine is 1/2. At 45 degrees, we have that both our sine and cosine have the same measure, which is the square root of 2 divided by 2. So we're going to find these same values, just with whether they're positive or negative being the only difference, at all our angles of rotation that are multiples of 30 degrees or of 45 degrees. So here at 120, 135, 150, and notice now also when we're at this point, 180, we have, again, exact values for sine and cosine of 0 for the sine and -1 for the cosine. So these points that are marked on the circle here represent these crucial points where we can determine the exact sine and cosine. So if we take a look at those points, we have all their angle measures marked in degrees here. So we have 30, 45, 60, this is 90 degrees, 120, 135, 150, 180, etc. But we also have everything marked in terms of radians. So again, as a reminder, a radian is an angle measure equal to 180 degrees. So when we rotate the full circle, that would be a rotation of 2 pi. What that means is that every 30-degree increment is an increment of pi over 6. So 30 degrees has a radian measure of pi over 6. 60 degrees is 2 pi over 6 or pi over 3. 30 degrees is 3 pi over 6 or pi over 2, and etc. all the way around the circle. Every angle that's a measure of 45 degrees then would be in increments of pi over 4. So 45 degrees has a measure in radians of pi over 4. 90 degrees is 2 pi over 4 or pi over 2. 135 degrees is 3 pi over 4. 180 degrees is 4 pi over 4 or just pi radians. So we can now look at the coordinates of these points here, and really what you'll see is that there's not that much to remember in order to commit this whole circle to memory. We know that at our four intercepts we have coordinates of 1, 0, 0, 1, 0, -1, and oops, this should read -1, 0, and this is truly 0, -1. Notice also here that we only have 3 different values. We have 1/2, we have √3 over 2, and we have √2 over 2. So those are the only 3 that you really need to commit to memory. And so when we think about, for example, at the 30-degree mark, we know that our x value is greater than our y value, so we're going to have √3 over 2 and 1/2. And again, that means the cosine here is √3 over 2. When we get to 45 degrees, we know that they're going to be the same measure, so they're going to be the value that's in between 1/2 and √3 over 2, which is √2 over 2. Another way of thinking of this is that you could think of 1 as √1. So our values are just √1 over 2, √2 over 2, and √3 over 2, and you just need to figure out and have a way for remembering which value goes with which angle measure. Once you can do that in this first quadrant, then it's fairly straightforward just to figure out how that corresponds to values here in the second quadrant, values in the third quadrant, and values in the fourth quadrant.